So let's look at the periodic table and talk a little bit about it. We will spend more time in Unit 3 talking about the periodic table. First of all, there's 118 known elements. The periodic table that is in the reference table does not go all the way to 118 because the from like 113 to 118-ish was not clearly established until 2016, and the periodic table that's in the reference table was printed prior to. So sometimes when you pull up versions of the periodic table, row 17 might not be completely full. There are 7 periods or rows on the periodic table. So you have row 1, 2, 3, 4, all the way down. These last two that look like they're pulled out of the periodic table are not rows. They actually belong in rows 6 and 7. They're removed from the periodic table because it makes the periodic table short enough to fit on a piece of paper, plus another reason that we'll talk about when we get to Unit 3. So periods and rows are horizontal, and there's 7 of them total. Groups and family are your columns. They go up and down, and there are 18 total. Names don't always match symbols, so while you're looking at the periodic table and you're looking for a specific element, just know that sometimes the letter and the symbol don't match. So, for example, if we find sodium, sodium is not S, that's actually sulfur. Sodium is Na, it's number 11 on the periodic table. The symbol is coming from the Latin word for sodium. If we look at chlorine, now chlorine is Cl. It does have the letter similar, but notice that the H of chlorine is kind of skipped over. So just be aware that it's not always the first 2 letters in the name either. Potassium is another one that is based on its Greek or Latin word, and is K for potassium. It's number 19. Finally, you do have those elements whose English name matches their symbol. So like oxygen is O. So sometimes it's easy, sometimes it's not. As you go throughout this year, these elements will become, and symbols will become more familiar to you. I'm not asking you to memorize the periodic table because you would always have one in front of you when you're taking your quiz and test by using the reference tables. But it is nice to be familiar with them. So I do suggest that you kind of just look over. The first 18 are really good to know, maybe up to the first 30 or so. There are 3 main spots on the periodic table. Metals. Now the elements that are metallic are good conductors of heat and electricity. They're malleable, which means we can shape and mold them. They have luster, which means they're shiny, and they're ductile, which means you can pull them. They're to the left of the stairs. So on your periodic table, you should have a bolded line over here. This one is red, that shows, or orange, that shows the stair step. That stair step, and yes, that's the technical name for it, separates our metals from our nonmetals. So anything that is to the left of the stairs is considered a metal, which is all in blue. Now hydrogen is an interesting element, and we'll talk more about it in Unit 3, but it is a non-metal hanging out with the metals. So just know hydrogen's not a metal, but everything else to the left of the stairs is. Non-metals are to the right of the stairs plus hydrogen. Metalloids are along the stairs, so it kind of makes its own staircase. Aluminum, though, is not a metalloid. Anything else that touches the stairs is a metalloid. Aluminum is not. Polonium, number 84, could be argued. So sometimes you'll see that that is half-colored metalloid and half-colored metal. But for our purposes, anything that touches the stairs is a metalloid except aluminum. Now, metals are good conductors. Non-metals are poor conductors, which means they're insulators. They won't conduct heat and electricity. They'll hold it in. Metalloids are semiconductors. So we use our non-metals in the insulation of our homes to keep the heat either in during the winter or out during the summer. And we use our metalloids in our electronics so that the circuit board and the systems in there don't get overheated as they're working with the electricity. So you should be able to find an element and say if it's a metal, nonmetal, or metalloid. So remember, sodium was number 11. It is to the left of the stairs, so it's a metal. Sulfur, which is number 16, is to the right of the stairs, so it is a nonmetal. Silicon is number 14. That's what's used in computers. It is along the stairs, so it's a metalloid. Next we have the composition of matter, and this is all of it in a concept map form. You've gone over these vocabulary words when you did your vocabulary cards on the first day of school. So you know elements are on the periodic table. They're a group of atoms with the same number of protons. Compounds are two or more types of atoms chemically bonded together. And those are what we call pure substances. So up here where it says substances, I would even write the word pure. So pure substances are either elements or compounds. Then you have mixtures. Mixtures, you have more than one substance put together. If they have the same look to it, you can't see one substance apart from another substance, then that's homogeneous. If you can see the different substances that make up that mixture, then it's heterogeneous. All right, so we have some examples over here, and we're going to place them in. So sucrose. What is sucrose? You should know that from biology. Sucrose is sugar, one of our forms of sugar. Well, sugar is not a mixture. In fact, it's a compound. It's made out of carbon and hydrogen and oxygen. Salt water. Here we have a mixture because we have salt, which is one type of substance, and water, which is a different substance, and they're together. Now, is it homogeneous or heterogeneous? Well, can you see the salt apart from the water? No, it all looks the same. Therefore, salt water is a homogeneous mixture. All right, Rocky Road ice cream. So Rocky Road ice cream is that ice cream that has the nuts and the marshmallows and the chocolate swirl going through it. So it's a mixture because you have all these different substances combined, and it's heterogeneous because you can see each of those substances in the ice cream. All right, what about air? The air that you're breathing. It's not a compound. In fact, it's a mixture. There's lots of different things in the air. We breathe in oxygen, we breathe out carbon dioxide. So there's two right there for you. You also have ozone, which is what we're worried about with climate change. You have nitrogen and helium and hydrogen and all sorts of pollutants in the air as well. So air is actually a mixture. Now, is it homogeneous or heterogeneous? It's homogeneous because you can't see the different things that make up air. You can't look around your room and see a clump of oxygen in one corner and a clump of carbon dioxide in another corner. It all looks the same. All right, what about aluminum? Like aluminum foil. Well, that's an element because that's on the periodic table of elements. It's number 13. The symbol is Al. So that's an element. Lastly, we have fog. Fog is when you have water molecules suspended in the air. So we have two different substances, air, which in and of itself is a mixture, and water. Well, you can see the water because that's how you see fog as opposed to non-foggy mornings. So fog, which is actually called a colloid, is a heterogeneous mixture. And we'll talk more about solutions, colloids, and suspensions when we get to our solutions unit later on in second semester.